Hey, hi everyone. This is my very first video on this channel, and then so I was thinking what topic to take, and then I've taken out trigonometry. So, like, why? And many will be feeling trigonometry very tough, and then they're studying why should I study trigonometry? Why? Why should I study trigonometry? And many will be, in fact, you'll be happy if trigonometry is removed from the from this current scenario, because the current scenario, if this chapter was removed, and many will be very happy. Okay, that's for sure. And but I'll make sure that, so in this video you will completely get why should we use trigonometry, and you'll be able to relate the trigonometry to around you, what is happening around you. That's more important. And I'll not discuss same the old age examples, that what is a Qutub Minar, to find height of a Qutub Minar, to find height of a Mount Everest, or river crossing problems. Definitely I'll discuss those things in maybe in coming up episodes. But in this episode, completely, why should I learn trigonometry? Like, what is the use of trigonometry, and like exactly what applications are there, that we'll discuss it. And at the end of this video, and I'll put disclaimer now only, if you watch this video completely, you will not get a single mark in the board examinations. CBSE class 10 board, you will not even get a single mark, but you will start loving trigonometry. That's for very much sure. Okay, so let's stop beating around the bush and let's start the so what is trigonometry. I'm not telling what is trigonometry at all. Okay, so let me start. Where do you use trigonometry? The first thing, so do you know that the current which comes to your house is trigonometry? The current is trigonometry. Seriously? You may ask me, sir, current is trigonometry. No, no, no. I have, it is there in the class 10 science chapter, that it comes in physics. There's a current electricity. So you say it's a trigonometry. Yes, it is trigonometry. So I'm saying that, so the current which comes to your house is trigonometry. What I mean to say is, current is not trigonometry. Yes, I do agree with you, but current can be modeled. Current can be modeled using a trigonometric as a function. Let me take an example. Now, how sir it is basically. So let us take that you have seen this armature coil, everything, right? You will be learning this in the science also. Don't worry, I'll teach you the science physics chapter also. That time you'll learn it in case you have not learned. So it is rotating, something rotates. So this is something an armature coil, and the magnets will be there. And when it rotates, then there comes the current which flows like this. And this is alternating current, an AC current, and it's coming every day to your house. Because of that only everything is working. Why do you use AC only? Why can't you use motor? That's a different question. Again, there's a different story. And then let's stick to this only. And so it goes like this. So what I'm saying is, something which is rotating, that can be converted into one of the trigonometric function which is known as sine theta. I'll tell you what is a sine theta. Some kind of something, some ratio, something called sine theta. It's a one of trigonometric ratio. And how it is converted? This is the AC current. And how it is converted, sir. So how this is this? I'll explain that. Okay. So now basically, if you take, so if I take a circle, just imagine I am taking a circle. Okay. So a circle I've taken. Okay, I think it's a perfectly circle, nearly circle. And imagine that basically what happened. There's a point. So let me donate. Locate this point here, and then so this point is moving in a circle like this. It's moving, and then this point comes somewhere here and like this. So imagine, like, basically that point has some kind of line. Imagine this line is there now basically. So this point is moving. So this is the, we call something called as direction vector, but don't worry about that. That's just a point, some line. Okay. And what I'm doing is, I am putting light from this side. I mean, basically I'm putting a torch. So light I'm going to put like this side. And then when I put a light here, what are you going to get? For example, I'm standing here. So there's a light here, there's a light here, and all. They're both, the lights are getting cancelled. One light is the image, you can get the image. If I am standing, if the sun is going like this, sun is rising, you can see my image, right? It goes, and when it comes to top, it comes back. Again, sun goes like this, my image will go this side. So you can see, as the sun goes in a circular motion, the image, your image is like going the distance. Basically, I'm talking about the distance of the image. It's going and coming, going and coming. Like a similar case, I'm trying to find what is the image of this line. If I project like this, if I have any line, if I project it like this, I'll get this one. So this is this image. So if I put a light like this, I'm going to get, this is the image of this. If the line goes up, so this is my image, this is my image, this is my image, and then this, like, the point goes here, this is one, this one, like this, like this. And when the line comes like this side, again I'm going to get an image like this. I mean, in this case, you can put the light from this side, and again you're going to get this is my image, and again like this. Okay, what we can see, the image of this line, it is starting from, zero and going all the way up, again coming to zero, again going in the reverse direction. So if I take these lines and if I plot them, so initially it was small, then big, then little big, then little big, then it attains a maximum value, then it becomes small, then it becomes small, then it becomes small, like this. Then it goes in reverse direction, similar way, like this. Again increases, 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 then decreases, then decreases, then decreases. That is, if you jot all these lines, what are you going to get? That is this one. So now basically, whenever you rotate something, so wherever there's a rotational dynamic, something called rotation, we have a lot of things rotating, right? Motor is rotating, car is going, and a lot of things are rotating actually. So whenever there's rotating things are there, so you can convert that into trigonometry. So trigonometry can be used in everywhere where there's rotation. There's something called sine theta, cos theta, and then secant theta. So many things are there. So we use. And one more thing is, so all of you are used to this coordinate system, right? Coordinate geometry. That's x coordinate and y coordinate, and then so that is called coordinate. We also have one more system of coordinates, and that's called radial coordinates, because something rotates, right? It doesn't move anywhere. So we need to have one more kind of system of coordinate geometry, which is called radial system. There's also something called parametric form and all. Don't worry about all those things, you will learn it later. And then even in that, so we have complete one more system of a geometry. So Cartesian system is gone. So I mean, not gone, it can be used for x and y coordinates. So when something rotates, we can use something called as radial coordinate systems. Again, that's a trigonometry, something called as r cos theta, r sin theta. I don't tell you about all those things. So trigonometry is used in the rotation, wherever something rotates. So that can be converted into function and can be used everywhere. So you can see that here also it is used. Now one more thing, like missiles. Let's take, so we have a lot of enemies. India has a lot of we have a lot of enemy people, and we have the country, as a country we have a lot of enemies. Okay, so you have some enemies, you can also put a missile on them. Okay, and then okay, fine, so you should know trigonometry for that. Putting a missile, your friend is staying somewhere there and you want to put a missile on him, so you need to do trigonometry, or you want to throw something on him, you should know trigonometry. Okay, so the missile has traveled till here. Now understand, basically, so it has certain altitude, and then it is something called as range. So how do you calculate this? At what altitude is going on, what range it is going on? If you know the target, if you know the distance from you to the target, or maybe India to one more country, you know the other country. Okay, and then if you have the distance between them, you can perfectly design a missile which can exactly go and target a particular location. So trigonometry is not a lot in everything in missiles. And not only missiles, today rocket science. So, and maybe 100 years back or just 50 years back, we never ever thought there's a rocket which goes to space and comes back again to the same location. So today we have the technology. I mean, still we are developing at India, but maybe you may be one among them who can, developing at a faster rate. And so what happened basically, so there's a lot of complications involved here. Just imagine a rocket. First of all, Earth is rotating. So Earth is rotating at a very high speed. So Earth is rotating, and then basically the rocket goes to space, again come back to same location. So what is that angle? So trigonometry, it involves a lot of trigonometrical equations which has to be solved to arrive at that what height speed should be there, what height it has to go, and all those things. So even in the, so that Elon Musk and all is doing a lot of things on that. Even if you go to rocket science, rockets and space exploration, space, because we measure in the space, we measure things not in kilometers, because kilometers is nothing, we measure in terms of radians. So there's something called trigonometry related again there also. You can calculate distances using trigonometry. And again, rocket also, the space exploration things and all, you can use it, goes and comes back and all. And not only that, even gaming. So can you imagine gaming? And even the gaming also. And then I know, ninth and 10th, you're all quite, you are very fond of gaming. Even not only you people, you big elders also, they love gaming actually. And even in fact, recently the PUBG has come, and then I don't know the problem with the PUBG. See, the PUBG is a very great game. There's no doubt in that. The problem is that they're selling all your data to some other country. I mean, they're using all your data. They may influence you maybe at the later stages, and they can influence the markets. They can, they can influence our economy and all. And now, why don't you think to develop a? You are all playing games, PUBG, like anything actually. But anyone thought like why this PUBG works like this? There's something called shooting, and even I heard some other game like some called Firefox or something like Free Fire, something like that. Okay, even there are a lot of shooting games over there, even smallest Mario and all. So if there's some jumping is there, right? How exactly, if if a particular jump like this, exactly how much distance it goes, why it falls here only? Have you ever thought like why it happens in the gaming? So a lot of gaming also involves a lot of trigonometrical things behind running that. And in fact, I was just checking one of the YouTube video where there is a software engineer. I think he's around seventh or eighth. He's a software engineer working in one of the company, being at this age, eighth or ninth. Now you're all learning trigonometry, but there are some students who already people are working as an engineers in a company. I think his age is 8 or 9. And I just read briefly about it. So he was one day playing a game. He asked his dad that why this goes like this, how this gaming works behind this. And luckily his dad was a software engineer, so he explained everything, and he developed so much interest. And today he's doing coding at the age of 9, or maybe or 8, I think he is. So understand, so basically, so gaming also involves a lot of trigonometrical equations, and a lot of trigonometry where angle comes and where things come. Not of rocket gaming, and not only these things, a lot of design sectors, the sound engineering, healthcare sectors. Sound engineering also, waves goes like this, right? So very much ocean waves goes like that, gravitational waves, and earthquake designing. You can design a building which is earthquake, because the seismic waves comes like in trigonometric functions. You can design an earthquake resistant building. So many things. Even your design industry, you want to cut a frog or something like that, certain angle and all. So what are the software used for that, right? That runs behind the mathematics. So basically, so even the gunshots, that whatever. Yeah, I was reading that even the wherever there's a detective works are there, right? Even they're using trigonometry actually. So at what angle the gun was fired, so that we can calculate where the person was standing and all. So lots of things are there. I think if I speak, I can speak the entire day. I can speak. So basically, what I want to tell, trigonometry is basically one kind of mathematical tool. It's a mathematical tool, so you can use this for anything you want. So it is not just this only. There's a lot of mathematical tools, not just trigonometry. So I have lots, like there's something called calculus, is there, integration, differentiation, vectors, 3D, probabilities, statistics, coordinate geometry. So many things are there. It is not just one this tool. So basically, trigonometry can be used in combination of other tools. Like trigonometry is not like just only trigonometry. Trigonometry comes in integration also. There's something called integration. Don't worry, you'll learn in 11th or 12th. Okay. So trigonometry can be used even the vectors also. Trigonometry can be used in statistics. Trigonometry can be used in probability. Probability, there's something called probability function, is there something. Don't worry about that. So trigonometry is the even probability also. So if I tell, I keep telling about this the entire day actually. So I hope you got an interest for trigonometry, because basically trigonometry is there everywhere. So mathematics is the backbone of science. The If you just go in depth of science, and you'll find the mathematics. Okay. And I hope you liked it. And then this is Rajendra Prasad. My aim is to simplify your minds. And thank you so much for watching, and happy learning. And if you like it, give a thumbs up and share with your friends. Thank you so much.